Okay, in question 2 and 3, we're looking at some possible integer values for a certain expression given an inequality. So here we're given this inequality here that x is between -4 and 5, but not including those values, and it can be a real number. We're given this expression here, so we're looking for the possible integer values of y. So I think a good way to go about this is to start by making an expression, making y the subject of the expression. So if we add 3y to each side, we can see here we'd have 2x plus 9. Adding 3y would remove it from the left. Have 3y on the right. And let's make it a little bit easier to have y on the left-hand side and divide by everything by 3. And we'd have 2/3 x plus 3. So we're told that x can be between -4 and 5. So let's take those values here. If we substitute them in, the y value would take those values in between 2. So let's see, 2/3, if we substitute -4, of course this can't be included. And what do we say, plus 3? And on the maximum side, we've got 2/3 multiplied by 5 plus 3. Let's do a bit of simplification now. Multiplying the fractions, we get -8/3 plus 3. And y is between that and 10/3. And let's simplify this 3 so that it has a denominator of 3. It's 9/3, and that's the same over here as well. So we have 9/3 minus 8/3. Well, that's just going to be 1/3. And here would have 19/3, adding the numerators. And that's about equal, well, we know that 18/3 is 6, so that's about equal to 6. Now we're asked to find the possible integer values. Well, if we take that, then here the possible integer values are all the ones in between these two values. So everything between 1 and 6, 4, 5, 6. And a lot of time, sometimes in the MEB, you'll ask for the sum of those integer values, and you just add those up. And we can check this just very quickly. You can fast forward the video to the next question if you're not interested in this graphical approach. We can also check the ideas here by looking at this equation here. So we could start by saying, yes, we know the y-intercept is here at 3, and it's positive slope, so it's going to slope upwards from left to right, and we could draw in something like this. Now we know that the slope of 2/3 means that if we have the run of 3, we'd go up 2, so 3 across, 2 up, and that pattern would continue, 3 across, 2 up, and also in the opposite direction, 2 up, 3 across. So this value here would be -3, and if we continued that pattern, we'd end up with something like this. So we're looking between -4 and 5, so they're looking somewhere between here, and if we've gone across 3 here, somewhere between there and there. And if we read across here, then we can kind of see, well, yes, 1 will be included there. This actually, we can say exactly what it will be. This value here will be 1/3 because we've already calculated it. And for 5 up here, 19/3. We can just double check that looking at the y values here. From 3, we've gone up 2, so that would be 5, and a little bit more as well. Not quite 2 up, so not quite to 7. So 7, you'll notice, is not included in our set. Likewise, 0, not included. So we can get an idea just from this equation here to check if that's correct, or even use a graphical approach to solve it as well. But this written approach is probably the intended method. So let's have a look down here at the maximum and minimum integer values. This time it's a little bit different because we're told that x and y are integers, and we're looking for the maximum and the minimum values. So let's do them separately. So for the maximum, we want this 2x to be as big as possible. So we could say 2 times the biggest number here. Now the biggest value here would be 4. That's the integer that's less than 5. Minus, now to make this really big, we want to subtract a negative value. So 3, the negative value for y, the smallest value here looks like it'll be minus 2. So if we calculate all of this, we get 8 minus 6. Actually, let's do that in an extra step. And if we add those together, 8 plus 6, we'd get our maximum value is 14. Alright, so now let's find the minimum. So for the minimum, 2x, the smallest value of x, it looks like it has to be minus 1. So minus 1 minus, we want to have something, subtracting something very large here. So if we get 3, the largest value, less than 4 would have to be 3. Alright, so then we've got minus 2 minus 3 times 3 is 9. The minimum value must be minus 11.